Hello friends, today I am going to teach you about data preprocessing methods. It is that contains the few steps. They are cleaning data, integration, reduction, transformation and discretization. The data is cleaned and integrated from the different sources and combined, and the reduction, the data which is redundant, it is removed. It's just inconsistent data is removed, and the data transformation, it makes the data accurate. Let's see all the stages in detail. In data cleaning, there are two types: missing values and noisy data. If there are missing values, we just ignore the tuple if only the tuples consist or more amount in the tuples. If there are less tuples, it should not be performed because it affects the accuracy of the data and filling the missing value manually. This approach is time consuming and may not be feasible given a large data set with many missing values. Using a global constant to fill the missing values means we use a global constant like unknown or don't know, null. We place the null or unknown value in the tuple area. Use the attribute mean or median of the samples belonging to the same class. From the same class we take the mean or median, or we just use the most probable value means mode as the missing value. We use it and keep the value. Second, noisy data. Noisy data is the random error or variance in the measured variable. It can be solved by two steps. One is binning. Binning method smooth a array sorted data value by consulting its neighborhood. Here, in an example, the data consists 4, 5, 9, 12, 15, 24 in the data. They are arranged in the ascending order at the first, and it is divided into subparts. Let's take three parts: 4, 5, 9, 12, 15, 24. Now we just need to find the mean of the above three numbers and the below three numbers. It is 6 and 17. The values 5, 4, 9 are transferred to 666, and 12, 15, 24 is transferred to 17, 17, 17 as we find the mean values 6 and 17. The values are replaced, and similarly it can be used as boundary values. Suppose 4, 5, 9 we can use as boundary value as 9. We can take 9, 9, 9, and here we can take 24 or 25, 24, 24, 24 like this. In the regression technique, another technique, it conforms data values to a function. It can be done by linear regression and multilinear regression. The linear regression, it is used for 2D dimension, and here multi-regression, it is used more than 2 dimensions. The attributes can be used to predict the other attributes. Data integration. Data integration is nothing but merging of data from multiple data stores. Careful integration can help in reduction and avoid the redundancies and inconsistencies. This can help improve the accuracy and the speed of the subsequent data mining process. Problems occurs when integration. There are three problems occur. They are entity identification problem, redundancy and correlation analysis problem, and tuple duplication. In entity identification problem, real-world entities from the multiple data source should be matched. Sometimes, if there are two databases we are combining, one database contains customer ID and another contains customer number, but both are the same values. But the problem arises when the entities names are different, but it should understood that both are the same values and consider it. Second is redundancy and correlation analysis. An attribute may be redundant if it is can be derived from another attribute and set of attributes. Inconsistency is attribute or dimension naming can also cause redundancy in the resulting data set. Redundancy can be detected by the correlation analysis. The correlation analysis are two types: first for nominal data and the numerical data. The numeric data can be found by covariance formula, and the nominal data can be found by correlation formula as given in the image. Tuple duplication. Tuple duplication should also be detected at the tuple level. Use of denormalized tables in another source of data redundancy. Inconsistency of arises between various duplicates. Due to inaccurate data entry, updating some but not all the occurrence. This duplication can consist inconsistency in the table. Data reduction. Data reduction techniques can be applied to obtain a reduced representation of the data set that is much smaller in volume. There are three types of data reductions. First is dimensional reduction, numerosity reduction, and the data compression. In dimensionality reduction is the process of reducing the number of random variables or attributes using consideration. Strategies used are wavelet forms and principal components analysis. In numerosity reduction, techniques replace the original data volume by alternative, smaller forms of data representation. The techniques may be in parametric or non-parametric. The parametric methods are data parameters need to be stored instead of actual data. They can be done by regression and log linear models are examples. Non-parametric methods for storing the reduced representations of data include histograms, which are similar to the graphs like bar graphs, but there are no spaces between it, and the bar graphs breadth and length are different. Clustering, we cluster the finding the same group of similar elements, and the sampling and data cubing can be performed. The data comprehension, compressed relation of the original data. If the original data can be reconstructed from the compressed data without any information loss, the data is called as lossless. The data is compressed in the size so that it can be used in an effective manner. Data transformation strategies. It is the final step where it consists the 6 steps. First is smoothing, which is removing the noise from the data. This technique includes binning, regression, and clustering. Attribute construction. Here we construct the new attributes which make the simplification of the mining process. And aggregation. Aggregation where summary or aggregating the operations and applied to the data used to constructing a data cube for data analysis and multiple abstraction level. Normalization. In the normalization, the new tables are created in the normalization where it shows the accuracy of the data, easy to arrange the data. And discretization, where the raw values of the numeric attribute are replaced by the interval labels. Example 0 to 10, 11 to 20 be the age, and it can be changed as youth, adult, or etc. Concept hierarchical generation for nominal data, where attributes such as street can be generalized to higher level concept like city or country or location. Many hierarchies for the nominal attributes are implicant within the database schema and can be automatically defined at the schema defined level. Thank you for watching.